The Corn Laws from 1815 led to a debate about specialization and trade, and we're going to illustrate that discussion with this example here. So let's consider the production of two sets of toys. So we're going to produce paper airplanes and baseballs. And in our synchronous session or face-to-face classes, we're actually going to be making airplanes and baseballs. So we're going to do this activity and create our own set of data. But for these videos, we'll use a set of data from a previous class. So what we're going to do is we're going to have two groups, country A and country B, that are producing paper baseballs and paper airplanes. If you're country A, then every time you make a baseball, and we're going to make our baseballs by taking our scrap of paper and wadding it into a ball. So country A, every time you make a baseball, you're then going to count to 10. 1, 1,000, 2, 1,000, 3, 1,000, all the way to 10. Once you've counted to 10, you can then grab your next sheet of paper and create your next baseball. Now, if you are country B, every time you make a baseball, you are then going to count to 5. 1, 1,000, 2, 1,000, 3, 1,000, until you get to 5, and then you'll make your next baseball. So already we can see that country A has less of an advantage than country B, because country B only has to count 5 when country A counts to 10. We expect country B, if they have the same number of people and the same raw materials, country B should produce more baseballs than country A. Now, we're also going to look at the production of airplanes, and here we're making paper airplanes. So if you're country A, you're going to make a paper airplane, right? So a very simple kind of fold here. I know you can probably make much more complicated and fancy airplanes, but here we have just a very basic, simple airplane. Okay, not even sure it really flies very well. But if we make a paper airplane, if you're country A, you'll make this airplane and then you'll count to 10. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, all the way to 10. And then only then do you start making your next airplane. So if we did this for 2 minutes, we could see how much country A could produce of airplanes. We could do this activity for 2 minutes and see how much country A could produce of baseballs. Same thing for country B. We could look at 2 minutes of baseballs, or we could look at 2 minutes of airplanes. And if you're country B, for the airplanes, you make an airplane, count 1, 1,000, 2, 1,000, all the way to 20, and then you make your next airplane. So in our synchronous session or face-to-face classes, we'll be making those baseballs and airplanes and using that to develop our data for the next couple examples. But because this is a video, we do want to illustrate the theory and show you how this works. So we'll assume we have done that activity, and we will then create this graph here where we have country A and country B. And we have our baseballs and airplanes. If we produce for 2 full minutes, okay, then country A will make 122 baseballs. Or in the same 2 minutes with the same number of people, country A can make 72 airplanes. Now these numbers are based on the production from one of my fall 2017 classes. In your class, in your semester, you'll come up with different numbers. So right now we'll work with this problem set, but then for your other parts of this course, you'll be using the ones that you developed in your class. So country A can make 122 baseballs or 72 airplanes in 2 minutes with the same people and resources. Country B can make 185 baseballs in that 2-minute period of time, or 51 airplanes. And we could see, just given the parameters of this activity, that country B should be better at making baseballs and country A should be better at making airplanes, simply by the amount of time that we have in between the activities. And we can see that here because country B can make more baseballs and country A can make more airplanes. Well, the first thing we want to do is create what is called a production possibility frontier. This illustrates the combination of two goods that a country or a company can produce. So for country A, we said they can make 122 baseballs or 72 airplanes. So if they used all their people and resources to make airplanes, that put us here at 72. If we used all of our people and resources to make baseballs, then we can make 122. The production possibility frontier shows the combinations of baseballs and airplanes we could make. So for example, we could decide to split our time between airplanes and baseballs. So here, this was in 2 minutes. They can make one or the other. But what if we split the time between? So what if we spent a minute on airplanes and a minute on baseballs? So then it's no longer or, we're making some of both. So if we spend half the time on baseballs, we would make half the number of baseballs. So country A would make 61 baseballs. And if they spent the other minute on airplanes, they would make half the number of airplanes. So 72 divided by 2 is 36. We can show this on our production possibility frontier. We're going up 61 and over at 36. Okay, so that is a single point on the production possibility frontier. One possible combination of airplanes and baseballs where the resources and time are being split equally. But it's also possible to divide up your workforce into different combinations focusing on airplanes and baseballs, or to devote different amounts of the 2-minute time on airplanes and baseballs. So all the possible combinations appear on our production possibility frontier. So based on the production possibility frontier, we could choose to make 20 airplanes and 20 baseballs. Wouldn't use all of our people, wouldn't use all of our time. However, we cannot make 140 baseballs and 100 airplanes. It's outside the production possibility frontier. Given our current resources, our current number of workers, the production possibility frontier is the outer bounds of what we can produce. We can make all airplanes, we can make all baseballs, we can make some combination in between, but we can't make out here with the current amount of resources, people, and time. All right, so that's for country A. Let's look at country B. So let's create a production possibility frontier for country B. Again, country B, if they spent all of their time and resources on baseballs, so the full 2 minutes, they could make 185 baseballs. 185 baseballs. And if they spent all their time and resources on airplanes, they could make 51 airplanes. We could also look at the option where country B makes some airplanes and some baseballs. So perhaps they take the 2 minutes and they split it so that they're making 1 minute on baseballs and 1 minute on airplanes. So country B would make half the number of baseballs as they made before. So we take 185 divided by 2. Okay, and we get what? 92 and a half. Can't make half a baseball. So if we're looking at it on a table, we would put whole numbers of baseballs. Our graph can illustrate those fractions because that is the true split of time. But if we're actually comparing tables and data here, we want to represent only completed items. If we spend half of our time on airplanes, well, before we were spending 2 minutes and we made 51. And now if we're spending a minute on airplanes, we're making 25. So if we put that on the graph at our 92, right on the graph, it's represented as 92.5. But our table, it's going to be only whole numbers, and we round down because you can't have half of an item. And we had 92 and 25, really 25.5 on our graph. And we connect those dots. So here's our PPF for country B. So notice country B can make 51 airplanes. They could make, what was that number? 51, 185 and 185 baseballs, or they could make a combination of the two. Again, country B could choose to make 20 airplanes and 20 baseballs. It would not use all of their time. It would not use all of their resources. Country B could not, however, choose to make 200 baseballs and 100 airplanes with the current number of people and resources and time. So that production possibility frontier is that constraint, that outer limit for what a country or a company can produce when we look at a combination of two goods. Now, sometimes we look at this in terms of consumer goods and capital goods rather than specific ones. If we're looking at a particular business, we can look at two different products that they might make. But you're just doing a comparison of two. All right. So we've created these production possibility frontiers. We have our table here that shows how much we can make of one or the other. And we have our table here that shows the combination if we divide our time. If there is no trade, then what you produce is what you consume, which means country A could make only baseballs and have 122. They can make only airplanes and have 72. If they decide to split their time or resources, one particular option is a minute of each, in which case country A would make 61 baseballs, 36 airplanes, and make a total of 97 goods. Country B, if there is no trade, can make 185 baseballs or 51 airplanes. Can't have both. If they do want to have both baseballs and airplanes, they have to split their time or resources. And one possibility is that they split it half and half. So they make 92 baseballs, 25 airplanes, for a total of 117 goods. Now, the reason we're looking at this here is because we want to start looking at theories of specialization and trade. So we want to have this as the benchmark. So here we have no trade. What you produce is what you consume. If you want to enjoy it, you have to make it. So we want to use this as a comparison once we start to specialize and trade. And I didn't quite leave myself enough room, but let's look at the total of baseballs and airplanes and the total number of goods that are produced in total. So 61 plus 92, if they're both making baseballs, 153 baseballs get produced and 153 get consumed. For the airplanes, if country A makes 36 and country B makes 25, then collectively 61 airplanes get produced. Okay, and what we produce is what we consume. So country A and B together will consume 61 airplanes. That means the total number of toys that are made, the 153 baseballs plus 61 airplanes, give us a total of 214 goods. So we're going to use this table here as a comparison when we start to specialize and trade. And so I think your table looks like this. So if I just put it over here, 61, 36, 97, 92, 25, 153, 61, 214. Okay. So this is the no trade example that we're going to compare to.